Hi friends, today we will see BJT characteristics, bipolar junction transistor characteristics. So generally characteristics means it is BJT characteristics, that means BJT is a switch. So to get the characteristics we need to apply some voltage and we need to get the corresponding current, and the graph between voltage and current is the characteristics. Very simple. So, but coming to BJT, this is a simple concept for two terminal devices. Okay, for example, if it is a diode, we can simply say only one voltage, only one current. So we can simply we can give some voltages in a stepwise and we can get the corresponding currents. And the graph between voltage and current give us the characteristics. But coming to BJT, BJT is having three terminal device. So as BJT is having three terminal device, so it should have three different configurations, with making one element common to both of the, making one terminal common to both of the other terminals, keeping one terminal and the common terminal as input and another terminal and common terminal as output. So beforehand, let us simply quickly go back to the transistor diagram. This is the symbol of transistor. So this is the symbol of transistor, and this is base, this is collector, and this is emitter. So it is emitter, so at this place only I have to mark the direction. As I have marked like this, so it is from, current always flows from P to N. So it is P and it is N, so this is also N. So this is the diagram for NPN transistor. So now we can see we have three terminals, one is base, collector and emitter. So now in three configurations I can make any one of them as common. For example, in my first configuration I may make base as common, so that configuration is called common base configuration. And in the second type I can make common emitter, and in the third type I can make collector as the common terminal. So common collector, common base, common emitter and common collector. That means if I make this common base as common, then what will happen? I can make emitter as the input side, emitter base as the input side, and I can apply voltage here, and this will be my output side. I can apply voltage here. Okay, so this is the main concept. Okay, in this way we can give different voltages. We will see from where we can give voltages and how to capture them, how to measure them. Those things we will see, okay, in detail. So these are the basic configurations: common base, common emitter and common collector. For example, if we have taken common base characteristics, then what are the different characteristics we can take? Okay, let me take common base configuration, then what may be different characteristics out of which. So these three characteristics, these three configurations, each configuration can have three different characteristics. So we have three different characteristics in each configuration. So they are, so the first one is input characteristics, input characteristics, and second one is output characteristics. The third one is current gain characteristics. So these three are the different characteristics in each of the configuration. Now we will see deeper into it. That means under the heading of common emitter characteristics, okay, we have these three, and second one is under the heading of common emitter characteristics, we have these things, and under the heading of common collector characteristics, we have these three. So let us go one by one. Now I will draw different configurations: common base, common emitter, and common collector configurations, and later I will draw a table such that which parameters are the input parameters, which parameters are the output parameters, and which parameter we have to make constant, which parameter we have to vary, which parameter we need to obtain for different characteristics. Okay, so till now we have discussed three different configurations, in which in each of the configurations we are having three different characteristics. Okay, now before going to this, I like to draw the diagrams of common base, common emitter, and common collector configurations. Then we will come to a conclusion such that you can easily identify which one is input and which one is the output. So please let me draw common base configuration, common emitter configuration, and common collector configuration. So please observe here, I am drawing common base configuration here. So this is common base. So for common base configuration, so for these things I am using PNP transistor. So this is very important point, so I am writing here. So I am using PNP transistor so that the current direction and the majority carrier direction is same. So now, so to draw this one, this is common base characteristics, so base should be downside. So let me draw like this. And this is ammeter. This is base, so base is common to both of them, and this is also one more ammeter. So this is the voltmeter. This is the voltmeter. That means here I am taking input voltages, input current, and output voltage and output current. So this is, and one more point I like to write here, either emitter or base should be the input based on the availability. Okay, so here base is like this, base is common, so obviously I can make emitter should be my input, so left side will be the emitter. So how to proceed? So it is PNP transistor, so let me write P here, N here, and P here. So current flows from P to N, so it should be like this. So this is the direction of current, this is the transistor now. So first one is emitter, so left side I am writing this one, so here it should be. Now we also know that input should be forward biased, so P should be connected to positive terminal and N should be connected to negative terminal. Okay, it should be like this. Of course we can have one resistor here to stabilize the current. That's all, and this is also the variable. Similarly here this side also, this side it should be reverse biased, so negative should be connected to positive. This is also one common point I need to write. Input should be forward bias and output should be reverse biased. So these are the important points we need to keep in our mind for all these characteristics. Now I can give the namings. Now let us name the currents and voltages. So how to deal with it? So the first one, this is emitter as we know, and this is collector and this is base. So as this is the base emitter, so this voltage will be VEB. As base is common, we need to maintain base as the last term. So similarly here it is collector base, so CB. As base is common, we need to maintain B as the second element. So the current passing through emitter is IE, and current passing through collector is IC, and current passing through base is IB. So this is the drawing of common base configuration. Of course this is also variable. Okay, now let's move on to the drawing of common emitter configuration. So now it is common emitter. So for common emitter, so emitter is common, so obviously input should be base. Okay, so as input should be base, the diagram should be like this. So it is ammeter, should be connected like this, and here also one ammeter will be there, and it is connected like this. So it is for, this is PNP transistor, so let me write here P, N and P. So it is PNP transistor. So how to proceed? This is N should be, and forward bias should be, input should be forward bias, so N should be connected to negative terminal like this, and here it should be connected to, so it should be connected to this one for reverse bias. So reverse bias means both are positive here, but you can take like this. Yes, it has been maintained like this. So this is also negative, and here also it is negative, and positive is connected to this base. And anyhow one resistor will be there to stabilize the base current. This is the variable and this is also the variable, and this is the voltage. Now we need to write the name. Yes, coming to names, so this is, here it should be positive to negative, so this is emitter, and this current is base current IB, so its direction is like this, and this is emitter. Here for the direction also no need to worry, always emitter current is inside the transistor, and base current and collector currents are out from the transistor. So this is collector current IC, and base current should be reversed. You just see here. Yes, so it should be, base current should be like this. Okay, emitter current is inside the transistor, and base current and collector currents are out from the transistor. So this is the concept. Okay, and this voltage is named as VBE. BE, as emitter is common, so second term should be common terminal. So now this is VCE. Okay, now let's move on to drawing of common collector configuration. Yes, so common collector configuration. So here again base should be the input, emitter should be output, and collector should be the common. Okay, so this is the base. So I am drawing ammeter here. After that, small resistor, same thing, it is forward bias, and every time make a note that emitter should be connected to positive. Okay, so again this is ammeter. See, above one is emitter, so it is P to N, so direction will be like this. Again it is positive. I hope I can write this point on top. Emitter is connected to positive voltage always. Okay, then it will be easy for us to draw the diagrams. Okay, and input voltage is a variable. It is a variable and it is also a variable, and this is voltage across this terminal, and this is voltage across these two terminals. So these are the laboratory diagrams also. So in laboratory also we need to do like this. Okay, we need to connect all these voltmeters and ammeters, and we need to identify various currents and various voltages for getting the different characteristics. Now we can give the names. So this is base current, so IB. This is out of transistor, and this is collector current IC, so this is also out of transistor. This is emitter current IE, this is inside the transistor, it is coming into the transistor, and IB and IC are going from transistor. So these are the things, and voltages are V base collector, so VBC. This is V emitter and collector, VEC. Okay, so this is the way as how to draw different configurations: common base, common emitter, and common collector. Now how to go ahead about characteristics. So how to deal with the input characteristics, output characteristics, and current gain characteristics. So I will make a small table type of thing so that it will be easier for us. Okay, thank you. Now we can see the different parameters in it. So the first in, let us consider common base configuration. In common base configuration, what are the input parameters? So parameters means it should be voltage and current. So the input parameters means input voltage is VEB and input current is IA. So it is VEB and IE. Similarly, output parameters are VCB and IC. VCB and IC. So let's move further. And what does it mean by input characteristics? Okay, I want to cover common base configurations completely. So let me cover one complete row first. Okay, so coming to input characteristics, So for each characteristics there are three parameters. One is constant parameter, variable parameter and obtained parameter. So here for input characteristics we need to make output voltage VCB as constant, and we need to vary input voltage VEB, and we need to obtain input current IE. So the graph between input voltage and input current is called input characteristics. Okay, so this is for the input characteristics, means this is the definition of input characteristics. And coming to output characteristics, output characteristics means we need to keep input side parameter constant. So here we need to keep input current as the constant IE, and we need to vary output voltage VCB, and we need to obtain output current IC. So this is called output characteristics. So coming to current gain characteristics, current gain characteristics means we need to keep output voltage constant, that is VCB, and we need to vary input current IE, and we need to identify the output current corresponding to input current IE. Okay, so we need to make VCB constant, and we need to vary IE, and we need to obtain IC. So this is complete set of common base configurations. So coming to common emitter configurations, again we need to see input parameters, output parameters, and all these three characteristics by seeing the diagram itself. So let's move on to common emitter configuration. In common emitter configuration, so the input voltage is VBE, VBE, and input current is IB. Similarly, output voltage is VCE, output current is IC. And coming to input characteristics, we need to keep output voltage VCE constant, we need to vary input voltage VBE, and we need to obtain input current IB. Yes, so output voltage is VCE, it should be constant, and we need to vary input voltage VBE, and we need to obtain input current IB. So these are the input characteristics of common emitter configuration. So coming to output characteristics, so output characteristics means make input current constant, that is IB, and vary output voltage VCE, and obtain output current IC. Okay, let's move on to the current gain characteristics. So current gain characteristics keep output voltage constant, that is VCE, and vary input current IB, and identify output current IC. Okay, so in the similar fashion we can go ahead with common collector configuration also. Please find the input current of input voltage and currents of common collector configuration. So this is input voltage VBC, and input current is IB, and output voltage is VEC, output current is IE. And coming to input characteristics, the output voltage VEC should be constant, and input voltage VBC should be varied to get corresponding input current IB. And coming to output currents, output characteristics, so please keep input current constant, that is IB, and vary output voltage VEC, and identify output current IE. Okay, so coming to current gain characteristics, so make output voltage constant, that is VEC is constant, change input current, identify output current, IE. Okay, so these are the different configurations and different characteristics, and if you can draw the diagrams first. For drawing the diagrams, so these are the basic points we need to remember. We are taking PNP transistor for our convenience, and we are making either emitter or base should be input, and input should be forward bias and output should be reverse bias, and emitter is always connected to positive terminal of the voltage source. If you remember these things, the drawing of the diagrams is very easy. So once you draw the diagrams, then identification of input voltage and input current, those parts also we have discussed. Once you know that, then you can easily make this table done, and you can usually go ahead with the characteristics. Okay, in the next video we will discuss only common base characteristics. That means input characteristics, how the graphs look like, and how the output characteristics look like, and how the current gain characteristics look like. Okay, so those parts we will see. So kindly follow my YouTube channel, and please subscribe to my channel, and please like this video, share this video with your friends and family. Thank you so much. Have a nice day.